friends, welcome to my YouTube channel. So in this video I'm going to discuss about one more robustness check for ordinary least square regression. So let's start with the data that we have, and I'm using this data for the past few videos. So this data I've already imported from my desktop on this data. Now first thing is that when we run linear model, linear regression, suppose while running linear regression you need to have a dependent variable which is pre-market underpricing, and the other independent variables, underwriter, rank, technology, venture capital, and suppose one more is small firm dummy. So here I have control variables, all the control variables, and one independent variable which is standard deviation of recommendation. This, right? Now these all are my independent variables, control independent variables, and this one is my independent variable for which I want to find a relationship between pre-market underpricing and standard deviation of recommendation. So this is the regression model I have. I'm using robust standard errors, right? So when I run my model, this is my model, right? This is how my coefficients, the coefficient of standard deviation of recommendation comes out to be negative and significant at 5% level of significance, right? But this is ordinary least square regression, which I need to have some robustness check to. So earlier in my videos I discussed about two-stage least square regression. It supplements this regression. Then I discussed about propensity score matching, how we can run it on Stata. Now today I am going to tell you about one more robustness check, which actually transforms our dependent variable into more robust variable in terms of its skewness, right? So let's talk more about it now. Let's talk about pre-market underpricing this particular variable in detail. So I have this variable with me, and let's draw a graph of this variable, histogram, right? So where you have to go to the graphics, and then you have to go to the histogram. Then you have to choose the variable for which you want to create histogram. This is pre-market, right? Everything else will remain the same, but one thing is, if this particular box is not checked like it is checked here, then you have to convert it into data are continuous, because we are not we don't want to make our variable histogram as discrete histograms, right? Data should not be taken up as discrete, and our data is actually continuous, it is not discrete, so that's why we are taking this particular checkbox. Now we click on OK. So this is our distribution of histogram of pre-market underpricing, right? And this particular distribution actually tells you a lot about how this pre-market as a variable actually behaves. So actually you can look at these graphs or these histogram of this particular pre-market variable, but more meaningful interpretation can be made when we draw a simple curve like this to this particular variable, right? So this particular curve actually tells you that this is not normal, but because it is this particular curve is having one end elongated towards the right side, that's why it is right skewed distribution, or it has right skewness, right? So this particular distribution, if this is right skewed and if this pre-market underpricing variable is following this distribution, then we can say that whatever the interpretations that we will make related to this variable by using ordinary least square regression, then those interpretations would be biased. That's why we have to first of all make this variable as a normal variable, make this variable's distribution as a normal distribution. For doing it, we have to convert this particular variable into normal distribution variable, right? So for converting it, we have to use a logarithm of this variable like this. So let me show you how we can do that here. So this is my variable here. I have this is my pre-market underpricing variable, right? Now related to this, I've created its logarithmic form here. Yes, this is my logarithmic form, transformed pre-market underpricing, this trans PU, and this is how I have transformed it into logarithmic form. Logarithm of 1 plus this variable, right? So 1 plus this variable, and I have transformed it for all the data sets, right? After transforming it, if I'll run again, I'll run the regression of this transformed variable, then this regression would be more meaningful. So I'm taking trans PU as a variable now, and this is again this trans PU variable, a bit of you can say this variable is now being transformed to normal distribution, and this variable's in relationship with the standard deviation of recommendation again is negative, as it is shown in the negative coefficient, and significant at 5%. So friends, I hope you have understood this demonstration. With the help of it, now you can use or you can remove the skewness from your data from any variable and make the interpretations more unbiased, right? So that's all for today. In my next video, I'll talk about more on research, and that's why you are required to stay tuned to my channel. Thanks a lot for your watching. Kindly like and subscribe my video as well as share it. Thanks a lot. Thank you so much.